So you guys should already be able to do these 5 questions on the class opener on your own, right? Let me go over number 3, and then you guys should for sure be able to do number 2. And I'll also go on number 5. That way you guys could do number 4. So what do I do on number 3? I need to get rid of that square by square rooting and square rooting. So I will have an x plus 5, no more square, equaling, whenever I apply a square root in an equation, I must put a plus or minus in front of my answer, which is 3. Okay? Now, I still need to get rid of that plus 5, so I'm going to subtract 5 on both sides. Now, whenever you subtract or add a number to a plus minus term, whatever it is, I suggest rewrite it, no matter what. So I'll rewrite the minus 5 first, and then the plus or minus whatever second. Once again, rewrite the minus 5 first, and the plus or minus whatever you have second. Then you could split that into your 2 situations, your negative 5 plus 3 and your negative 5 minus 3. So negative 5 plus 3, that's going to be a negative 2, that's one answer. Negative 5 minus 3, it's going to be a negative 8, that's your other answer. Does everybody understand what I just did? Excellent. Okay, so now you guys could go back and do number 2 and number 1. Go for it. Actually, you know what? Before going for it, let me go to number 5. And let me show you how I'm going to do number 5. That way you could do that with number 4. So on number 5, normally I would subtract 9 and subtract 9 to get it equal to 0, right? And think like, what times what is C, that if I combine together is B. But before doing that, I recognize that this is a perfect square number. So this might be a perfect square quadratic trinomial, which means that I might be able to factor it into this. So what times what is 25 that if I would add together is 10? Anybody? 5 and 5, right? Which means that I could actually rewrite this binomial times its exact binomial. I could rewrite that as a binomial squared with the x plus 5 right there equaling 9, which means now I could go back and square root both sides and solve that way, right? Square root, x plus 5 equals plus or minus 3. Subtract 5. Rewrite your answer. X equals, put the minus 5 first and the plus or minus whatever second. Now, if you have plus or minus square root of something, plus or minus I, plus or minus 3i, you stop right there. But because they're both nice numbers, you could actually add and subtract both of these nice numbers. So let's go negative 5 plus 3. And let's go negative 5 minus 3, getting us our 2 final answers of negative 2 and negative 8. So I believe you guys could do the rest of these. Go for it. I'm pausing it. Go for it. Okay, so for the sake of time, here are the answers to number 1 and 2. Should have gotten plus or minus 3. Should have gotten a positive 2 and a negative 8. So if you need more time on this slide, you could hit pause on the video from home and watch this. Number 4 should have been the answers positive 2 and negative 8. Okay, so I hope you guys got that right. Let's move on to the next part of this opener. So the goal is to end up with a binomial squared. So we want a perfect square quadratic trinomial. In other words, we need perfect C values right here. So what number would be the perfect C value that would allow this to be a perfect square quadratic trinomial? 25. That's great. You guys already know that. How about on this one down here? 16. Good job. How about number 7 over here? I'm going out of order. 9. Wait, only one person, or does everybody know? 9. Now again, the goal is to think what perfect square number would work right here that when I factor it, I get that binomial with that same value, which would be plus 3 and plus 3, right? So it looks like you guys understand it. How about number 9? What would this one be? 36. Okay. How about number 10 right here? 81. Why? Because 9 times 9 is 81, and if I add it together, it gives me that 18, right? How about 11? 4. Why? Because 2 times 2 is 4, and if I add it together, it gives me 4. Now, you're coming up with these numbers pretty much from this b value, huh? So this one, everybody gets confused on this one. What would this perfect c value be? It's not 1. It's not 0. It's not 2. How about this? Let's go back to these guys. Like, you guys told me 81. You guys gave me this easily, right? You guys told me 81 right off the bat. But you only found this number by looking at this one. It was half. That's how we got the 9, right? And then we multiplied it with itself, right? So we need to do that same thing. Take half of your b, which in this case would be 9, and then multiply it with itself, which would give you that perfect c value, 81. So what would this be? Well, you have to take your b value and take half of it. What's half of 1? It's half. And then when you take half and multiply it with itself, 0.25 or 1/4, right? So your perfect c value here would be 1/4 or 0.25, whatever you want. It's kind of confusing on that one because we end up with fractions. So the numbers that you guys gave me, those perfect c values, believe it or not, what you're doing when you gave me the 25, when you gave me the 9, you guys actually completed the square without knowing it, right? So this method we're about to learn right now on these notes, 4.5, it's called completing the square. And all you have to do is find that perfect c value that you guys just found. And you guys did it on your own, but here's the formula. It's simply taking your b value, taking half of it, which is dividing by 2, and then squaring that answer. Okay? So you go to your b, whatever number this is. If it's an 8, it's going to divide it by 2 is a 4, and then squared, this will be a 16. If this is a 10, divided by 2, it'll be 5. 5 times 5 is 25. So you get that perfect c value by simply taking your b value, dividing it by 2, and then squaring it. Do you guys understand that? Okay. Now let me show you how this will work in action. Now, down here, how about this? Don't copy this down, right? Don't follow me. Just watch. Okay, because normally what I would do, like if somebody just gave me this problem, hey, I'm just like, oh, I need help. Could you solve this for me? I'd be like, okay, let me subtract 10. Don't copy this, all right? I would have x squared minus 10, plus 4x minus 10 equals 0. And then I'd be like, oh, set this up and try to factor, split, and solve, right? And then you start thinking, okay, what times what is c that if you combine together is b? Well, negative 1 times 10 or negative 2 times 5. Wait a minute. Neither of those work to give me the middle value 4. So it's not factorable. So I'd be stuck, right? So that's why I said don't copy this down, because I don't want you to be stuck like that. We're going to use completing the square, which is a new method. And it is a great method if your b value is divisible by 2, right? Because how are we going to find that perfect c value? By getting b, dividing it by 2, and then squaring it. So check this out. The very first step would be to rewrite it, but leave some space for the new c value that you're about to come up with, all right? You have the equal sign, you have the 10 on this side, and we might as well put the space on that side as well. So the very, very first thing to do is make sure that there's no number out here in the front. The a value has to be 1. If there was a 1, if there was like a 2, divide everything by 2. If there was a 7, divide everything by 7. You want to make sure that the a value is 1, and you want to make space for your new c value. So now let's complete the square by taking the b value, taking half of it, and then squaring it. So what's my perfect c value going to be? Say again? 4. Okay, so again, you take the b value, you take half of b, and then you square it. So that's 4 divided by 2 squared. So that's really 2 squared. What's 2 squared? 4. So our perfect c value is 4. Now you can't just magically add 4 to one side of an equation. It's going to be off balance. It's going to be heavier on this side, right? So if you add 4 on this side, you must add 4 over here to maintain the equality, to maintain the balance. So put plus 4 over here. Are you with me? So by me putting this perfect c value, I will now be able to factor it, but ultimately be able to write it as a binomial squared. Okay? So let's think about it. What times what is 4 that if I combine together is 4? 2 times 2, right? So positive 2 here, positive 2 there, which means that I could just put the plus 2 right there. And of course, this is equal to 14. And now I'm going to square root on both sides. I will have x plus 2 equals plus or minus. You have to put a plus or minus whenever you apply a square root in an equation. Square root of 14. Now, yeah, you're supposed to try and simplify 14, like break it down with multiplication, but 2 and 7, if you break it down to 2 times 7, it doesn't help you at all. You want a perfect square number. So like if this would have been let's say a 12, I'd break it down to 4 times 3 because 4 is a perfect square number, but it's not 12, it's 14. If it would have been a 20, I'd break it down to 4 times 5. But 14, you can't break it down to anything. 2 times 7, neither of those are perfect square numbers. So the only thing left to do is to get x by itself, which means I'm going to subtract 2 on both sides. And again, your final answer, you always write your number first and your plus or minus whatever second. So negative 2 plus or minus square root of 14. And that's it. So the method I used to solve this equation was called completing the square. I explained the steps, but obviously hearing them is not enough. Let's actually see them right here. So right here, guys, check it out. Step 1, make sure that the a value is 1. So if your a value is not 1, you got to make it 1. You have to divide everything by, like if you had a 7 out in the front, you have to divide everything by 7. If you have a 3 out in the front, you have to divide everything by 3. Okay? Make sure the a value is 1. And also you want to make space for your new c value. And where does that new c value come from? From taking b and dividing it by 2 and squaring it. And of course, you need to add it to both sides of the equation or else it will be off balance. Yeah, you have to add it to both sides of the equation. And then step 3 is to factor it, getting a binomial squared. That way you could square root, and solve your equation. Now on this step, I probably should not have put a plus or minus right here. I'm sorry. Let's just scratch that out and just put a plus. What I meant to say was that it could end up with a plus sign or it could end up with a minus sign, depending on your b value. So like if your b value was like a negative 8, then you'd have a minus sign. If your b value was a positive 8, it'd be a plus sign. But anyways, this is more of like a shortcut right here where you set up your binomial squared. That's like a shortcut. Let me explain. Let's take a look at number 1. Step 1 says make sure that what? A is 1. Is this 1? Yeah. All right, great. And it also says what? Make sure there's no space for c. Is there a space for your new c value? Because see, this is my old c value. I need my new c value that I'm about to come up with, right? So let's make space first of all. So let's subtract 86. Subtract 86. I will have x squared minus 18x, leave that blank spot, equals negative 86. And you know what? You might as well put the blank spot over there. This will help you to remember to add it to both sides to maintain the equality, to keep your equation true. So I need a perfect c value. What's my perfect c value going to be? 81. How did you get that perfect c value? You took your b value, the negative 18, and you divided it by 2. What's negative 18 divided by 2? 9. Negative 9. And then negative 9 squared, you square it. What's negative 9 squared? Positive 81. So we need to put a plus 81 right here and a plus 81 right there. Is everybody with me? Now, why the heck do I want that perfect c value? Ultimately, so I could end up with this binomial squared. Do you guys want me to show the work here, or do you want me to skip to the binomial squared part? You want me to show the work or skip it? Okay, so how about this? If I were to skip it, I just look at what letter I'm dealing with, which is obviously x. So on the binomial squared part, I'm going to put an x right there. And this missing value, guys, ladies and gentlemen, the missing value right here is simply going to be half of whatever your b is. So what's your b? Negative 18. What's half of that? Negative 9. So we need a negative 9 right in there. So that's what this part up here is talking about. You see how I have a binomial squared, and I have my big giant x right here, and then this missing piece right here is simply your b value divided by 2. So half of your b value goes right here in the missing piece. So that's how you skip some steps. Now, if you don't like skipping steps, you don't have to. You could have said, okay, I got my perfect c value. Now let me think. What times what is 81? that if I combine together is negative 18? So what do you guys say? What times what is 81 that if I combine together is negative 18? Minus 9 times minus 9 is positive 81, and if you combine it together, it gives you negative 18, right? So you see how you could just skip this step right here? You could go straight to the binomial squared part. There it is, binomial squared. Put the x, and then this is simply going to be half of b. So you could do that all the time. You don't have to show your work. You could just go to the binomial squared part, put the x, and this will simply be half of b. Now how about negative 86 plus 81? What's that? Negative 5. Thank you. Negative 5. What's my next step? Square rooting. X minus 9 equals plus or minus. You need that plus or minus, then what? What happens with that negative on the inside? I. Becomes an I on the outside. So don't forget that the I is out in front, and then you put the square root of 5. Yes, you're supposed to try to break this down with multiplication to get a perfect square number, but as you can see, you can't do it. So this is what we have so far. I still need to get rid of that minus 9. So I'm just going to go plus 9 here, plus 9 over here. My answer is x equals positive 9 plus or minus I square root of 5. That's your answer. Now, are these real answers or imaginary answers? They're imaginary. Do you guys know what that means visually? If I thought of a parabola, like let's say I had a y equals this stuff or a f of x equals this stuff, and I graphed the parabola, it opened up. I could find the vertex by doing negative b over 2 times a. But this parabola that opens up will not cross the x-axis because these are both imaginary answers. The plus or minus I, it would not have nice real x-intercepts. Anyway, I'm sorry, say again?
Only for x.
The x-intercepts, remember a couple of lessons ago on our wall, it said right there that the answers are the same thing as solutions, or the same thing as roots, or the same thing as x-intercepts?
You wouldn't be able to find the solution?
You wouldn't, well, this is the solution right here. This is,
But like for the solution for the parabola.
yeah, so there is no real solution, which means that the parabola does not cross the x-axis. So visually, and I'm getting way sidetracked here, visually what that would mean is that your parabola is something like this up here. Like your vertex will be above the x-axis itself. It doesn't cross. So normally you'd have it right here and you'd be like, oh, my answer's right here and right here. But in this case, if your answers are imaginary, that means that your parabola is opening up and it's above. It doesn't actually cross the x-axis at all. Yeah, I'm probably taking that too far. I apologize. How about we do number 2 right here? What's the first step? Yes, you need to make sure that that a value is 1. So let's divide by 2, divide by 2, divide by 2. And also on that first step, it says make space for your new c value. So we have k squared plus 8k, make some space, equals negative 6. Might as well make some space over there too. Alejandra, what do you say my perfect c value will be? If you don't remember, all you got to do is go to this b value and then take half of it. What would that number be? Half of 8. 4. And then you square it. What's 4 squared? What's 4 times itself? 16. So that's your perfect c value. Everybody put plus 16 right there. But again, you can't just magically add 16 to one side unless you do it to the other side. So add 16 to the other side as well. That way the equality stays true. Now, why did I want this perfect c value? That way I could rewrite it as a binomial squared. Yes, you could factor by putting a k here and putting a k there, thinking what times what is 16? But you could skip that. You could jump straight to the binomial squared, put the k right in there, and ladies and gentlemen, what's this missing piece? Where do I get this missing piece from? It's up on your notes. It's simply going to be half of b. What's your b value?
8.
What's half of 8? 4. So since that's a positive 8, it's going to be a positive 4. So everybody put a plus 4 right there. Plus 4. Equals what? What's negative 6 plus 16? 10. Negative 6 plus 16 is 10. Okay. Let's solve this thing now. Square root, k plus 4 equals plus or minus square root of 10. Subtract 4, subtract 4. K equals negative 4 plus or minus square root of 10. You can't break down square root of 10. 2 and 5 doesn't really help you at all. Neither of them are perfect square numbers. So you are done. That's the answer right there. What do you think? Okay. Which one should we do? 3 or 4? 3? Step 1 is to make sure the a value is 1. So what would I do to make it 1? Because right now it's 7. What do I do? Divide by what? Divide by 7, divide by 7, divided by 7, even the 0, divided by 7. We're going to end up with t squared plus 4t plus 8 equals 0. Might as well make space for our new perfect c value that we're about to come up with. So we're going to have t squared plus 4t space equals negative 8. What is my perfect c value? Michael, what's my perfect c value?
4.
Right here. What belongs right here? All right, how about this? How do you find the perfect c value? You go to b, take half of it, and then square it. Yeah, it's going to be 4. Right? Go to b, take half of it. What's half of 4? It's 2. Square it, multiply it with itself. 2 times 2 is 4. So your perfect c value is 4. And you can't just magically add 4 there unless you do it over here. So now that we have a perfect square quadratic trinomial, we could rewrite it as a binomial squared. I'm jumping straight to the binomial squared. What belongs right here? Anybody, come on. Half of b. What's half of b? So I'm going to put a plus 2 right here. Half of 4 is 2. So I'm going to put plus 2 right here. Now again, if this b would have said negative 8, then right here I would have put a negative 4. If right here it would have been negative 12, I'd put a negative 6. If right here it would have been 20, then right here I'd put a plus 10. If it would have been an 8, I'd put a 4 right here. Whatever you see here, put half of it right here, and you'll be good. Okay? On this side, you end up with a negative 4. And of course, you're going to apply a square root to both sides. T plus 2 equals plus or minus what? The negative comes out as an I, but the square root of 4 is what? 2i. Don't say I2. I2? No, it's 2i. 2i. The negative comes out as an I, and then the square root of 4 is 2. I times 2 is 2i. Final step will be to get rid of that plus 2. So go minus 2 there, minus 2 there. There's your answer. T equals negative 2 plus or minus 2i. Now, I'm going to let you guys try that one on your own. And what I want to do is take the next couple of minutes and jump to our assignment. Our assignment is this worksheet, and it's called Completing the Square worksheet, but the funny part is you're not going to be doing much of that, completing the square. This whole first part, numbers 1 through 8, by the way, we're only doing the odd ones on this first part. You don't have to complete the square because this is already a perfect square value. It's already your perfect c value. This could already be factored. What times what is 16 that if you add together is negative 8? Negative 4 and negative 4. You guys see how it's already a binomial squared, right? So x minus 4 squared equals 1. And then of course you square root. You get x minus 4 equaling plus or minus the square root of 1 is 1. Then you go plus 4. Then you rewrite it. You have x equals 4 plus or minus 1, which means you have 4 plus 1 and 4 minus 1, which is 5 and 3. So all of these 1 through 8 are already set up for you. They already have a perfect square value right there. So if this one's already a perfect square quadratic trinomial, you could factor it, or you could jump straight to your binomial squared. What's your binomial squared going to be? Negative 3. X minus 3. And you could continue by square rooting, right? Everybody's cool with that. So we're not even doing completing the square right here. we start doing completing the square on this next part. This is what we did on our class opener at the beginning of this video. What's the perfect C value right there? 25. Why? Because you simply take half of 10 and square it. Half of 10 is 5. 5 times 5 is 25. How about on this one? What's the perfect C value? 49. Yeah? Easy peasy. What's the perfect C value right there? 144. So that's the only real part of completing the square. Now down here on this part of the worksheet, by the way, we are doing all of these right here, 9, 10, 11, 12, 13, 14 on the worksheet. Then down here, we're jumping to the even ones only. Okay, now, first of all, I started looking at this and I started realizing this is horrible for completing the square. Okay, let's understand this. Completing the square is just a method, and there's many methods of solving equations. We're going to learn so many different methods, and you get to pick the one you're most comfortable with, all right? So it's pointless to force a certain method, especially if it's not the best method. Like right here, if you wanted to complete the square, you have to first make sure the a value is 1, right? Is it 1? Yes. Then you'd have to get the b value divided by 2, which would be 3/2 or 1.5, and then you'd have to square it, which would take you to the fraction 9/4. And imagine adding 9/4 to both sides. That would get really ridiculously ugly, right? So based on the skills you already know, which method would be best right here to solve this equation? Pull out the GCF, right? So what could you pull out? An x. What would be left on the inside? X plus 3. And then we're going to use the zero product property. If you have something times something and it equals 0, the first something could be 0 and the second something could be 0. So one answer is 0 and the other one's going to be -3. So you guys see how easy it is when you pick the right method? Now we could have completed the square right here and dang, it would be ridiculous. But it could be done. I could force it if I wanted to. Would this one be good for completing the square? Okay, if I asked you this, how do you start completing the square? Divide what? Half of b. So would this be nice? No, because it's 1, right? So you're dividing by 2, you'd end up with 1/2, and then squaring it, you'd end up with 1/4. That's ugly. I do not recommend completing the square on this one. So try another method that you already know. Even though this worksheet says complete the square, I do not recommend to do that, okay? What method would you use right here? Just factoring, right? The a value is 1, you might as well try it. Make a list if you need it. What times what is -6 that if you add together is +1? 3, +2. Oh no, backwards. -2, +3. And when you split it, you're going to get your two answers. +2 and -3. So we already know some methods that are really easy. Don't use completing the square unless it's a good problem to do so. Would number 18 be a good problem to complete the square? Heck yeah, finally. Finally a problem that we could actually complete the square that would work out nicely. If you tried to factor the way we've been doing, it's not factorable. So right here, the b value is even, so yeah, why not complete the square? So completing the square would be great on 18. So the reason why I'm frustrated with this worksheet is because 18 is good for completing the square. 19 is not. 20, it looks like it is, but it's not. You know why? Because you have to divide everything by 3 first. And you end up with 2/3. And it's not good to take half of 2/3. So the only problems out of this whole completing the square worksheet that are good for completing the square is 18 and 24, which by the way are on our homework. So don't feel that you have to do completing the square. Try any method that you can, right? So on number 20, which you have to do for your homework, are you going to complete the square on that one? No. Why not? Because you'd have to divide by 3. You get 2/3. You got a nasty fraction, right? So what method would you use? A times C, right? Step 1, A times C, you get a -3. Step 2, think of the multiples of -3 that combine together to give you the b value, which is 2. That would be a +3 times a -1. Step 3, rewrite your trinomial as 4-term polynomial so you could factor by grouping. That way you could split it and solve. Right? So always look for the best method to solve your equation. So completing the square is only going to be good on 18 and 24 on this one. Of course, you could force it, but 18 and 24 are the only ones that would be convenient for completing the square.